Hello. In this video, we're going to talk about what types are in Java. In the last video, we talked about this a little bit when we were talking about making variables, but in this video, we're going to cover specifically how the different types behave. In Java, there's two different types of types. You've got primitive types and you've got reference types. Reference types will be stuff like strings, arrays, and stuff that you can create yourself. However, they're more complicated and we'll get to them in a future video. This video is going to cover primitive types. These are types that are built into Java. The type name begins with a lowercase and the variable directly stores the value that you have written to it. The primitive types in Java are what you see on the screen. However, a lot of these types actually have very similar behavior to each other, and they're just storing bigger or smaller values. So in this series, I'm going to only cover the most common types. You can change them as your needs. Generally, you can try to make some optimization out of this. However, unless your program you're writing is very performance dependent, say maybe like robotics, a lot of the times this level of optimization is negligible. So in this series, we're going to talk about ints, doubles, booleans, and characters. You can say char. A lot of people like to say it in a lot of different ways. I'm just going to say character because it is easy to remember. So we're going to go through type by type. Ints are a numeric type. It's short for integer, which is basically whole numbers. You can see 3, -1, 0. Ints have the ability to range from -2 billion and change to just above 2 billion. And they are stored with 4 bytes. What bytes are, we will cover in a later section. And some useful operations for ints are assignment, comparison, and arithmetic. So let's actually step into some code here to see an example. So I have this int demo file. I've created a variable x. I've assigned it the value 7. I've created a variable y, and I have assigned it the value 3. Now, again, let's think about what we did in the last video. This whole declaration and assignment is the declaration. I've given x the type of int, and I've done an assignment, x equals 7. So now, take a look at what we have here. So these are arithmetic operations, and see if you can't guess what, and this is actually from a separate run, see if you can't guess what the result of each of these is going to be. So this one's going to add x and y. The minus subtracts y from x. This is multiplication. This is division. This is a remainder operation, and so is this. And then we also have our comparison operators. So this is stuff like greater than, less than, equal to. I'm not showing all of them here. They're fairly easy to get your head around, but I want you to take a second, pause the video, go 3, 2, 1, see if you can't guess what each of these values is going to be. And when we run it, so 7 plus 3 is 10, 7 minus 3 is 4, 7 times 3 is 21. Interesting thing to note, we've got 7 divided by 3 equals 2, which for those of you who have studied your math out there, we know that 7 divided by 3 is not equal to 2, but since we have integer types, it gets to a value and then rounds down. So 7 divided by 3, that's going to be just over 2 and some change. It's 7/3. But even if you had like 2.99999 and you have it as an int, it's always going to round down. It's going to do what's called truncation. So it won't ever round up as an int. And then you have this modulus operation, which is your remainder. So it'd be what's the remainder from 7 and 2. A nice thing to know about that is that 7 is an odd number, so it's always going to have a remainder of 1. If we gave it an even number, we do mod 2, it would always have a remainder of 0. This operation in particular, I will also make a separate video about, because it is a more complicated operation than addition, subtraction, multiplication, and division. And then we have a comparison operator, which will end up returning a Boolean value. Booleans, again, we've covered, they're just true or false. And we'll cover more on them later in the video. But, so we've said 7 greater than 3, and it returns true, because 7 is in fact greater than 3. You also have an operation that's less than. You can do less than equal to. You can do double equals. And we can say, let's just run it again, 7 equals 3. Well, that returns false because 7 does not equal 3. Again, I know we're covering revolutionary stuff here, but this is just going through the basics of doing these operations. Coming back to the slides, we have the next type, which is doubles. Doubles are another numeric type, but the difference between them and integers, among other things, is that they can store decimal values. You got 3.14, 2.78, negative 4.2 as some examples. They have more complicated behavior, so in this series I will not be covering exactly how doubles are stored compared to something like an integer, but they can have up to 15 decimal digits, which allows them to get to be large numbers or also very small precise numbers. They have 8 bytes that they use to store values, which again, bytes I will cover in a later video, and they have the same useful operations as ints do, which is assignment, comparison, and arithmetic. And I don't want to act like these list of useful operations by no means are comprehensive lists of what you can do with them, but they're just some basic things that we can cover in today's video. So let's go back to the code here. And I have a double demo, so I've stored x, we've assigned x to 3.5 and y is 2.5. And you can see this is going to have, I accidentally copied that, which I didn't need, and I can get rid of this, which I also do not need. But you can see we do the assignment, we do our addition, subtraction, multiplication, division. This division is actually going to behave how we expect it to, as opposed to integer division. And we can also do another comparison where 3.5 is in fact greater than 2.5. While we're on this slide, and I'll cover it more in depth in a later video, but you see these double slashes that don't seem to do much of anything. These are called comments. They don't actually tell the computer much. They're just for us as humans to read and help reason through our code. It's for a concept about readability, which should in fact be its own video. Back in the slides again, we have the boolean type. Booleans are very simple. They are true or false. They actually only take 1 bit. They take almost no usage space at all to store. And then a useful operator would be your logical operators, and still also assignment. And we can go ahead and take a look at what some of those operators are. So just like the other types, we do the assignment. We have a boolean x that we have assigned the value of true, and we have another one y that has the value of false. We can do this exclamation point. That means not. So not basically flips. If something is true, not true is false. And then we also do it the same way that if we say not false, it's true. So this should end up being false true when we print it out. We have this double ampersand symbol, which is the logical and. A logical and means that both x and y need to be true to return true. If either of them are false, it will return false. And this, the 2 vertical bars down here, is sort of a natural counter to that, which is the or symbol. For an or, if either of them are true, then the condition evaluates to true. Let's go ahead and run it. So not true is false, not false is true. So x is true, but y is false. So this is false, and then x is true. So this evaluates to true. I will show one other thing here, just as a quick clarification. If I run this or still comes out to be true. Don't think of it or like you normally hear it in English, where you say, do you want this or that? And you can only have one. This is just saying if either of them are true. So if X is true or Y is true, the thing evaluates to true. There is something called an exclusive OR, which means exactly one of them must be true. Uh, One thing you can do for that is you could also say does not equal Y, because if they can only have the value of true and false, and they do not equal each other, exactly one of them must be true. So we do that, and we get false for the OR, for the what is essentially an XOR, and we do that, and it comes out to true. Coming back to the slides one last time, we're going to cover the character type. Now, this is for sure me showing some of my bias after using Python for some extended periods of time, but I think it's an ugly type. Uh, it has some wonky behavior as you're starting to learn about this, and I don't use it much as itself. I'll use it in combination with a string. Just a quick editor's note, characters are for sure useful. They use very little storage, they're fast to work with, and they're necessary for certain operations involving strings, among other things. I am injecting a little bit of humor into this. I don't know how much you guys want pure education, or would you like some banter in these videos, but I also know that this is for people who have not heard what a character is before today, so take everything I say about characters with a grain of salt. I just have some personal bias. Also, let me know in the comments, do you want there to be humor in these, or should it be just a display of information? Anywho. But using it as a type just by itself can have some weird behavior, and I'll make a common bug video later in this series in case any of you guys run into this type of problem. Uh, so, as you can also see on the slides, characters store a character, which I bet you're wondering, wow, that's so surprising. But I've listed some examples that H can be a character, 3 can be a character, and I want to highlight this right here. Whoops. Uh, this has a space. This is not an empty string. This is a single space. That can also be a character. Basically, anything with a length of 1 put into single quotes, that's a character. And it takes 2 bytes to store. Let's go ahead and look at an example. In this character demo, we can see that I've just assigned this character C to have the character value C in quotes. And if I print C, it should give us C. And then you're already starting to see some wonky stuff. But I can say, is C less than A? Is C less than D? What the heck is this looking thing? And that. So let's go ahead and run it. And let's just take a look at this behavior. So when we print C, okay, that makes sense. We've said C is C. We print C, we get C. We say C is less than A, we get false. And we say C is less than D, we get true. That's starting to see like we could kind of have some guesses as to why it's doing that. But let's look at the next two, where I've done this weird C plus 1 and this weird character symbol again. And then I have C with this int in parentheses, and I get 99. So real quick, and I'm going to cover this more in depth in a later video, this parentheses type name parentheses is called a typecast, and it makes sure that when you evaluate an expression that it ends up being registered as the type that is in this parentheses. So when I say C plus 1, it would actually naturally convert it to an int, and then I am manually converting it back to a character just to demonstrate. And this is our character that would naturally be printed as a character, but I've told the computer instead, hey, I actually want to see this, whatever this value, whatever this expression evaluates to, I want to see its value as an integer. So we can see that C, this character in quotes, C, is equal to 99 as an int. This is what would be called its ASCII value. Basically, in order to print stuff to the screen, computers have this series of values that your characters have. Um, and I'm actually going to do one last thing. I'm going to do system.out.println. I'm going to do one more type conversion. A type conversion or typecast is really just, again, specifying that even though it's this type, I want to read it as this type. We should see one interesting thing here. Notice how D is 100. So there is some organization to these ASCII values. And I'm going to give you a couple seconds here to think. Maybe you're starting to make some more sense about this comparison and what this does. So in your own heads, try to reason about why that behavior is. I'm going to give you 3, 2, 1. We have this ASCII value of 99. We add 1 to it, we get to 100. And then we typecast it back to a character. That's why we end up with D. The original ASCII value is 99. We add 1 to that, we get 100. And then we get D's ASCII value, because that's what we've checked here, that D has an ASCII value of 100. Similarly, when we are doing these comparisons, it's actually going to do the comparison as ints. And we can see that C must have a higher value than A, but a lower value than D. Again, you're not going to see these types of operations all that often, but they can have some useful properties for sorting and other various tasks that you might need to complete. So it's good to know that you can do that with characters. In this video, we've covered the basic primitive types you're going to use in Java, in addition to some of the operators that those types use. We've outlined some stuff that we're going to cover in some future videos in more depth, but I hope at this point you feel comfortable to start playing around. Not that you're writing out full programs at this point, but that you can at least start seeing how these types, operators, and everything else interact and just get some stuff to print to your console. Make sure to like and subscribe, help out the channel, and I will see you guys in the next video.